Hello everyone and welcome back to Chanakya Online Campaigning. Today we are going to discuss the chapter Banking. From the word banking, it is pretty obvious that it refers to bank. And what do we do in bank? We either deposit or we withdraw amount. In this chapter, we are going to learn about recurring deposit. For a fixed amount of time, a fixed sum will be deposited in the bank. Say for example, I deposit rupees 1000 for 12 months. That means in the whole I have deposited 12,000. And this is called MI. So the money which I am depositing every month is 1000 rupees. Right? So let me call it X. Then we have the time. How much time? 12 months. You always need to convert the time if it's given in years into months. So 12 months. In the first month, say suppose I started depositing the amount in January and therefore next year in the same month it will stop. That is, in 12 months it will be over. In the month of January, I deposited at the rate of 10% per annum. And as you know, this is a recurring deposit. That means every month I will deposit the same sum. In January also I'll deposit about 1000 rupees at the rate of 10% per annum for 1 month. We'll calculate this. So it goes till December. Now what is this thing which we are doing? You know, whenever you deposit something, you get some interest on it. Over here, we are using the formula of simple interest or interest, that is principal into rate into time upon 100. So you see, this is the principal, this is the rate, and this is your time, right? Let's say that I deposited this much amount for this much time and this time is now over. So now I'm going to get some money along with interest. So that will be called as maturity amount. Means the amount which has been matured. Now, how will you calculate it? You basically need to sum up monthly investment and interest. So now we know three terms. Maturity amount, monthly investment, and interest. That means if you sum monthly investment and the interest, you will find the matured amount. From the examples which we have seen earlier, we saw that we were calculating the interest month-wise. But what if you have to calculate it in just one step? Like we did for January, we did for February, till that we did for December. Then what we needed to do, we needed to sum up the interest for January, the interest for February, and so on till the interest for December. Now we can apply a formula over here instead of this. What we can do is we take the X or recurring deposit, okay? So X is over here and we write the months and n plus 1 and we name it as P. Alright? Now how can you use this? How can you use? In the formula of interest you can write X into n plus 1 upon 2 into R upon 100, and the time should always be 1 by 12. So we can directly find out for the whole amount of time. In the last example we saw X was 1000. So we can simply find this, and now it has become less time consuming for us. Let us quickly find out. When you add 12 plus 1, it's 13. Rate was 10%. 12 and 12 will be cancelled. 2 zeros cancelled. 2 times 5. What are we left with? That is 10 times 13 times 5. So 13 times 5 is 65 and 10 times 65 is 650. Now we are supposed to find the maturity amount, that is monthly installment plus interest. So 12,000 plus 650, and we are left with 12,650 as the maturity amount or the maturity value. The formulas which we are going to use in this chapter, first formula is of interest. At every place the value of t will be 1 by 12. Monthly installment is n times x. Matured amount is mi plus I. I will be using Emil Agarwal mathematics over here. The first question. Mrs. Goswami deposits ₹1,000 every month in a recurring deposit. That is, let's say x is equals to ₹1,000 for 3 years. That is, n should be 3 years. But if you remember, I told you to convert it into months. That is 3 times 12. 36 months. Then we have the rate of interest per annum, that is 8%. We are supposed to find out the matured value or matured amount. So we already know that matured amount is equals to monthly investment plus interest. Now what do you require over here? First of all, you require monthly investment. And the formula for monthly investment is recurring deposit times the number of months. 1,000 times 36. That is 36,000. This is the monthly installment or investment. Next, we require the interest. So we will apply the formula x times n plus 1 by 2 times r upon 100 times 1 by 12. Let's write over here. Let's cancel. 12 times 3 is 36. 2 times 4 is 8, and 0, 0 over here, 0, 0 over here. So as you multiply, you will find out the value of interest to be 4,440 rupees, and the maturity amount is monthly installment plus interest. And you find out it to be 40,440 rupees. Let us now move on to question number 4. Since question number 2 and 3 are supposed to be solved in the same manner as we did question number 1, it says Hanif has a cumulative bank account. Now what is cumulative bank account? It is the same thing called recurring deposit. So it says he deposits 600 rupees per month. That means 600 rupees. For a period of 4 years, we are supposed to convert it into months, 48 months. If he gets rupees 5,880 as interest at the time of maturity, you are supposed to find out the rate of interest. That is, we don't know what's the rate and we are supposed to find it out. Now, let us see what do we have. You know that this is the major formula out of which these two have their own formulas, right? So let's see, what do we have? We have interest, but we don't have MI. But we can calculate it since monthly installment or MI is recurring deposit or cumulative deposit times number of months. So this is MI. We can find the maturity amount or the matured value. Now you know the formula of interest. We have the value of I, we have the value of X, we have the value of N. We don't have the value of R, therefore we'll keep it as it is. Now let's cancel. Firstly this and this 4 times, this and this 2 times, this 2 0, these 2 zeros. 5880 is equal to 6 times 2 times 49 times R. Let's transfer this value over here. Since here it is in multiplication form, therefore here it will become in division form. That is, R is 5880 upon 588. We find out that the rate of interest is 10%. Question number 8 says, Rekha opened a recurring deposit account for 20 months. The rate of interest is 9% per annum and Rekha receives 441 as interest at the time of maturity. Find the amount Rekha deposited each month. Here we are supposed to find out the amount which she deposited every month, not the monthly installment. We need to find out the recurring deposit. Okay, we know the formula of interest. If we see for monthly investment, that is number of months times recurring deposit. So it can be 20x start cancelling it. See, this when divided by 3 is 21. This when divided by 3 is 147. 7. That is, we get 7 times 40. Rupees 280. So now if you want to find out the maturity amount, yet it's not asked in the question, but if you want to find out, you can do the same thing over here. Mi plus I. You know the interest value? Mi 20 times x. So you'll multiply 20 with 280 and you can find out maturity amount. Let's see question number 9. Mohan has a recurring deposit account in a bank for 2 years at the rate of 6% per annum simple interest, and he gets rupees 1200 as interest at the time of maturity. Here we are supposed to find out the monthly installment as well as the amount which he gets at maturity. So as we did in the question number 8, how to find out the maturity amount, you will find it out in the same manner. Let us move on to question number 11. It says Samita has a recurring deposit amount in a bank of rupees 2000 per month at the rate of 10% per annum. If she gets rupees 83,100 at the time of maturity, find the total time for which the account was held. Maturity amount 83100. From here, what are we supposed to find
So
out?
as you are already aware of the formula of maturity amount, that is monthly installment plus interest. Over here, the formula which we will use to find monthly installment is x times n. And when we transfer the values, we get the value of interest to be 83,100 rupees minus 2,000x. We will consider that this is the exact value of interest, and in the formula of interest, we will put this value on the left hand side and the respective values of the variables on the right hand side.
So what we did, we put the value of interest which we find out over here on the left hand side, and the formula principal times rate times time. Okay, we have put the values as well. Now we are supposed to cancel. As we transfer 12 from the right hand side to the left hand side, we'll multiply this. Alright, so now we have to transfer these values, and what we can do is we can form a quadratic equation, that is 100n square plus 100n plus 24,000n. Now what we can do is we can divide all of the equations by 100. Now we need to find the value of n. Alright, so this equation kind of becomes too long to solve. We can find out the value of n in just seconds. You see the amount, maturity amount, its value is 83,100 rupees, right? Monthly installment we find out 2000 n. Now we are supposed to assume the value of n. Now if n was 12, the value of monthly installment would have been 24,000. But do you think on 24,000 you can receive 83,100 as maturity amount? That's quite not possible. If n was 24, that means 2 years we're talking about. We don't get satisfied yet. Now if you take the value of n to be 36, now this is the condition. 72,000, 83,100 rupees. Now let's move further. So let's say n is, so the value which we find is 96,000. Is it ever possible for you to deposit more money and get less amount? No, it's not possible. We are not satisfied with the first and the second part as well. But we can say that we have some kind of satisfaction with third part. So let us suppose that n is 36. Over here, one of the quadratic equations must be n minus 36. So that whenever it's transferred over here, it should be n is equals to 36. We are using 36n. It is required for us to use minus because it should be transferred to the right hand side and become plus. And what you need to do is, you need to find such two pairs that if you solve them, it should be this term, and if you multiply them, it should be this term. Alright. Over here we are going to take either of the equations. let's say n plus 277 is equals to 0. So what will happen when you transfer over here, your n will become minus 277. Now this is not possible since n cannot be in negative form. But taking out the second equation, n minus 36 is equals to 0. N is 36. We have a lot more satisfaction than ever. That means the time is 36 months. So with this, we complete the exercises of chapter banking. I hope that this video comes out to be useful for you. Make sure to subscribe to Chanakya Online Companion. You can follow us on Instagram. If you have any kind of feedback, suggestions, queries, you can discuss it with us on our Instagram account. You can also follow us on Facebook, Twitter and Telegram as well. Thank you so much for watching the video.